Good morning, everybody. Today, I am going to present the paper A Common Database Approach for OLTP and OLAP using an in-memory column database and written by Hasso Patlner, co-founder of SAP. So, they have listed several paper titles. I am not going to go through all the paper titles. I will summarize the paper and present you. My presentation outline will be Introduction, OLTP system, OLAP system, motivation, row store versus column store databases, their experiment and the benefits of column databases, data organization, and they have talked about memory consumption, contribution to the development of software, finally references. When it comes to introduction, relational database systems are used over 20 years as the backbone of the database. So, OLTP, online transactional processing, and OLAP, online analytical processing, are also basically based on relational, but they use different technical approach. Let's go through in detail what are OLTP and what are OLAP. Online transactional processing is designed database structure to cope with the more complex business requirements, and they need to focus on transactional processing. Here tuples are arranged in rows and they are stored in blocks. These blocks resides on disk and they are cached in main memory in the database server. They allow sophisticated indexing to fast access for single tuples. I have listed properties of OLTP, but I am not going to go through all the properties. I will go through some of them. When it comes to source of data, the OLTP data is operational data and OLTPs are the original source of those data. The purpose of the data is to control and run fundamental business tasks, and they reveal a snapshot of ongoing business processes. And in image, I have added 2012 SQL Server OLTP components. When it comes to OLAP, online analytical processing, they designed to perform analytical and financial planning. They provide more flexibility and better performance. And here, multi-dimensional cubes are used. For OLAP system, data is often organized in star schemes, and there were popular optimization is to compress attributes with the help of dictionaries. I have listed OLAP properties as well. The source of data. Here OLTP data comes from various OLTP databases. Purpose of the data is to help with planning, problem solving and decision support and multidimensional views of various kind of business activities. The motivation for this paper is to OLTP and OLAP are based on relational theory as I mentioned earlier, but use different technical approach. So it's desirable to have OLTP and OLAP capabilities in one system that will make very valuable components to the user. And on the other hand, the use of column store databases for analytics has become quite popular. Dictionary compression on the database level and reading only those columns necessary to process a query speed up and query processing significantly in column store case. So I will go through in detail what is row store versus what is column store database. When it comes to row store, easy to add new record, but they might read unnecessary data. When it comes to column store, they only need to read relevant data. Tuple writes may require multiple seeks. I'll go through simple example with 4 columns, 3 rows as you can see. In row-oriented database management system, the data would be stored as row. So as you can see, 1, John 8000, then semicolon. But when it comes to column-oriented database management system, the data would be stored like 1, 2, 3, then after that second column will be stored. So they have done an experiment with SAP application database, full table scan with 160 attributes and 34 million tuples. 1 million tuples take nearly 1 GB of memory, therefore 30 million of tuples nearly take 35 GB of memory, and column store database equivalent to table size of 8 GB. So here we have explained data access in row and column storage in detail. So why use column store? Most of applications in enterprise computing are based on set of processing, not in single tuple access. Therefore, there are so many benefits of column store databases. So it is not to particular tuple. Operation on tuples using compressed format of integer, and it allows for parallel processing, and scan can one or more columns is very parallelized. But here their recommendation is to use minimal of projections. When we go to parallel processing in detail, calculations on the level of tuples will automatically parallelize and completely independent of each other. Current CPUs can handle 1 MB in milliseconds, and parallel processing by 16 costs more than 10 megabytes per second. Here claim is to column storage is suited for update intensive application. Updates in column store database. So adaptation here is column store database suitable for update intensive application, and having all data in memory greatly improves the situation, but nevertheless some of problems remain to consider. And by analyzing the change log of 4 different SAP customers, they have come up with several updates types: aggregate updates, state update, and value update. When it comes to aggregate update, the attributes are accumulated values as part of materialized view. When it comes to state update, binary change of states variable typically with timestamp. And it comes to value update, the value of an attribute change by replacement. So let's go through these updates in detail. When it comes to aggregate update, the more instances of aggregates are requested, the better for the relative performance of the column storage. In a row store, the response time increases linear with the number of aggregates read, as you can see in the diagram. When it comes to state updates, states variables typically use predefined set of values. Therefore, they don't create problems when performing in-place update, since the cardinality of the variable does not change. When it comes to value, they have found that average 5% of tuples of financial systems are actually changed over a long period of time. So they have come up with concept called insert only. In insert only concept, they don't perform updates or deletes on physically in stored data tuples. Therefore, they add tuples, manage their validity to update or delete. As an example, if you want to update, they invalidate that particular current tuple and add new tuple with the new updated value. If they want to delete some data tuple, they invalidate that data tuple. The insert only approach has some consequences. So they have talked about some locking mechanism, application level locks, database level locks. I'm not going to go through in details about these locks. So data organization, when it comes to data organization, to build a combined system with OLTP and OLAP system, data should be organized for based on fast insert, maximum concurrency, and also low impact of reorganization. And they have also talked about memory consumption, comparing the memory requirements of row and column storage of a table. Different in compression rate is obvious. Different analyses of real data showed that column store compression rate is 20 and row store compression rate is 2. So, when it comes to contribution to the development of software, in rewriting the current applications, they plan to reduce the amount of code by more than 30% and reconstruct the main part using fully indexed nature of column storage, and as I said earlier, they use minimal projection. Finally, references. Thank you very much for listening.